Hey guys, welcome back to Naveen Automation Labs. This is Naveen here. So guys, today I'm going to cover very important Java topic that is called Java Memory Management. What types of different sections are there inside the Java memory, and what is JRE? What is garbage collection? How exactly it works? What are different types of sections are available inside the Java memory? Either it is heap memory or stack memory, and inside the heap memory also how exactly it is divided into multiple parts. It's very important if you are a Java developer, if you are into automation also, and if you want to know that okay how exactly internally JVM works in terms of memory management. It's really important for interview point of view also. Okay, so let's talk about it, guys. It's very important, very important topic in terms of interview. If you are going for some good companies for giving the interviews, and if they're asking about Java memory management, it shows your knowledge, it shows your expertise at okay how exactly expert you are, how exactly the internal architecture of JVM and Java runtime environment you are aware about it. Okay, so first of all I'll say you that okay everything is all about memory. Whatever you create in the form of classes, methods, objects, variables, methods, okay, everything is all about okay memory inside the Java. So how exactly it works, where exactly if I'm creating a local variable, if I'm creating a global variable, or if I'm creating different class objects, where exactly these uh, variables, objects, methods are getting stored. Okay, so if you see, first of all I'll say that okay there is a huge Java memory, and Java memory is divided. Let's see, this is a huge Java memory like that. Okay, and Java memory is divided into two parts. One part is called heap memory, another part is called stack memory. So first we will talk about heap memory. So if you talk about, this is the okay heap memory. Okay, this is the heap memory, I'll say. Okay, okay, so this particular heap memory, okay, sorry for typo mistake. So this particular Java heap memory, what exactly the purpose? So heap memory is again divided into two parts, guys. Okay, so I would say heap memory is divided into two parts. Okay, this is the first part and this is the second part. So inside the heap memory, these two parts are called, I would say, let's see, this is the first part is called young generation. Okay, young generation, and another part is called old generation. Okay, the second thing is old generation. Okay, so always remember, whenever we are creating any class object, all the class objects will be stored first time inside the young generation. Okay, let's say I'm creating a class object over here, so all these objects will be stored over here inside the okay young generation memory space. Okay, so whenever young generation is also divided into okay three major parts. The first part is, this part is called hidden. Okay, this is the first part, and there are two more parts are available. Okay, these are called survivor memory. Okay, so young generation memory also into divided into three parts. The first part is called hidden memory. Okay, this is hidden memory. This is let's see survivor. Okay, survivor memory, I would say, let's see, this is S0. Let me, okay, survivor memory. So this is S0, and another survivor memory, let's see, S1 also. So there are multiple survivor memories are available, okay, in the young generation. So in the young generation, we have three parts: hidden memory, survivor memory, S0, and let's see, survivor memory, S1. So what is the purpose of that? So whenever we are creating a new object, so new object always will be stored inside the hidden. Okay. So what happens that when the new object in the young generation, when it is completely filled inside the hidden memory, when there are, you are creating n number of objects and there's a huge application and so many objects you are creating, so hidden memory, it's having some own space. Once this particular space is completely filled up, what exactly it will do? Okay, one mechanism is called, that is called garbage collector. Okay, garbage collection mechanism will be called. So that garbage collection is called minor JC. Okay, minor GC will be called. Okay, minor GC will be performed automatically, and minor GC will be called. GC means garbage collector. So minor GC will come. It will check that okay, what is happening over here. Okay, that memory is getting full. So immediately, what exactly it will do? It will shift all the survivor objects into S0 and S1 memory, into S0 and S1 into survivor memory. Some objects will be shifted over here. Okay, from okay hidden memory to okay survivor memory, like this, from hidden memory to survivor memory. Once S0 is also filled up, then again it will be shifted to S1 survivor memory. So young generation is divided into three parts. Okay, so there are multiple garbage collections are happening. Let's see, minor. This is called minor GC because minor GC is very for very for short period of time, and it will say that okay, once a minor GC, let's see, first garbage collector got called GC1, and again second mechanism garbage collector 2 also called, then again GC3 is also called. So during there are so many garbage collector okay activities are getting called by the JVM automatically. Let's see, there are number of okay garbage collection up to GCN. Okay, all these garbage collector okay things are getting called. Now what will happen during this mechanism? It will keep checking that okay what are different objects are available which are ready for survivor, which are important. Okay, immediately JVM will shift all these objects to survivor memory. Okay, and when we have some objects are available which are having okay which are having no reference, some blank objects are available or some null references are available. Let's say I create the object test t1 is equal to new test, and the t1 is equal to null. The moment I write like this, and I'll create the object of test class t1 is equal to new test. Okay, and sometime it happens that okay t1 is the object is okay gone, and then it is pointing to null. T1 is pointing to null reference. So what will happen? Because of this, garbage character will be called. Because of this, garbage character will be called, and that particular object will be destroyed to free some memory. Okay, because garbage character, the mechanism, the task of garbage character, the duty or responsibility of the garbage character is that it will free some memory from the okay from the young generation memory. But there are some objects. It is we are creep we are there are 10,000 lines of code and it's a huge application. So there are so many objects we are creating for different classes. So number of objects are getting created. So memory is getting filled. Memory is getting full. The moment what exactly it will do, it will keep shifting all those survivor objects from okay from hidden memory to S0, or maybe once the S0 is also full or F0 is also full, then it will keep shifting those objects to S1 also. So this is called basic knowledge of like basic fundamental of young generation memory. Now we have another thing is that is called old generation memory. Now what happens then old generation memory when this S0 and S1 is also filled? There are no spaces are available in S0 and S1. So what exactly Java will do that? Java will shift all these objects into now the new object will be created inside over here. Okay, inside the old generation space. These objects are getting created over here with the different references. Okay, once this particular old generation is also filled up, and then Java says that okay Java feels that okay automatically that okay now this is the right time to call GC. So whenever we are performing any garbage collector on old generation, that is called major GC, major garbage collector. Okay, that is called major GC is performed when old generation memory is also full. And this major GC it takes okay time, it takes a lot of time, it takes a longer time I would say. Okay, so you have to decide very practically and very smartly. So whenever any Java developer, in fact for automation engineers also, if they are developing any Java application or any Java automation framework, if you are creating so many objects, you have to take care about young generation concept as well as old generation concept also. You should not create unnecessary objects. And if you are creating the object, immediately it should be destroyed by the garbage collector. So sometimes we see that okay, there are so many requests are coming on Walmart.com or Amazon.com, and there are so many hits are coming on that particular application. internally it's creating so many objects of that particular class. In that case, what will happen? Major GC will come into the picture. Major GC will try to destroy all these applications. So major GC will keep some memory. It will take some time. It will take some longer time as compared to minor GC. Okay, so minor GC is performed on young generation because there are less objects are available, and minor GC, okay, will take some smaller amount of time as compared to major GC. So that doesn't matter. But if you are performing major GC, the major garbage character at old generation objects, in that case, major GC will take some time. So sometimes we are getting timeout exception on Flipkart.com or something like that in holiday season, or maybe Diwali season, or maybe Thanksgiving Day. Okay, so sometimes we are getting, okay, timeout exception. Why? Because major GC is busy to destroy the objects. It's taking a lot of memory to destroy the object, and the number of processor and the CPU utilization will be high on the server. In that case, okay, we are getting, okay, timeout exception sometimes. So the major GC will degrade your application performance. It should be minimized. So major GC activity should be minimized. We should not call major GC on old generation, okay, very frequently, because once it is coming into the picture, immediately it will try to destroy number of objects, and it's going to take time. So it will give timeout exception or maybe timeout error sometime. Okay, so just because of this, we are getting timeout. Okay, timeout errors. Okay, just because of this thing. Now, so this is heap memory. So heap memory, always remember, is divided into young generation and old generation, like that. Apart from that, I'll tell you about heap memory. Okay, other things. Apart from that, we have another thing is called, that is called, guys, permanent generation. So one more memory is called, that is called permanent generation. Okay, this is called permanent generation. Okay, so that is another part of memory, that is called permanent generation. In permanent generation, guys, what happens in permanent generation, that what exactly that what kind of data will be stored, what kind of attributes will be stored over here inside the permanent generation. Inside the permanent generation, whatever the application metadata, okay, which is defined by the JVM to describe the classes and the methods, the entire metadata will be stored over here. Okay, metadata of your of classes, okay, of your methods, that, okay, what type of method it will be, what kind of classes it will be. Okay, so all these such kind of metadata will be stored over here inside the, okay, inside the permanent generation. But permanent generation is not part of the heap memory, guys. It is separately from heap memory. Okay, so not, I would say, not part of heap memory. Okay, and this particular permanent generation memory will be generated at the runtime. It will be generated at the runtime. So always remember that it will be generated at the runtime. So this is about permanent generation. So in permanent generation, we will do such kind of things. Okay, in permanent generation. So in permanent generation, what exactly we have? We have another concept is called method area. In permanent generation, we have another concept is called, that is called, this is one more thing is there inside the permanent generation, that is called method area. So method area is very important, guys. What do you mean the method area? This is called method area. In method area, what exactly we store? In method area, the complete class structure, okay, a complete class structure will be stored inside the method area. All your static variables, okay, all your static variables and all your constant variable and define number of constant you're defining, all those, okay, constant variable and different static variables will be stored inside the method area. So always remember, method area is part of your permanent generation. Method area, class structure, static variable, constants are not part of your heap memory. Heap memory is only and only for, okay, only and only for objects. Okay, there are some other things also I'll tell you. So this is about permanent generation. Apart from that, we have a memory pool also. In what exactly we do in memory pool? Because in memory pool there are some other things also, that is called memory pool. In memory pool, what exactly we define? Let's say this is a memory pool. Memory pool is part of your heap memory. Okay, now What do you mean by memory pool? Memory pool to store immutable objects, guys. Memory pool is used to store immutable objects. What do you mean by immutable objects? Means we have a string class. Okay, we have a string pools. Okay, so all these objects, okay, all these variables, the string objects and everything, all the immutable objects will be stored inside the memory pool. Okay, and this will be defined, it will be defined at the runtime, okay, at the runtime by JVM memory managers. They will be activated at the runtime and they will define all the immutable objects like string class objects and string pools. Everything will be stored inside the memory pool. Okay, inside the memory pool like this. So this is another concept of memory pool inside the. Now we have another pool is also there, that is called runtime constant pool. Okay, well, now what do you mean by runtime constant pool? Okay, so we have another concept that is called runtime constant pool. That is again very important. That is called runtime constant pool. Okay, in runtime constant pool, what exactly happens that, okay, whatever the part of method area, okay, that constant runtime, okay, static variables and all those things which will be stored, okay, inside the, okay, over here, not inside the heap memory, it will be stored over here. So let me correct it. It is part of your runtime constant pool, is part of your permanent generation. It will be part of your method area. So it will be part of your method area. Okay, so again in runtime constant pool, that it will be part of your method area. Again, it will be generated at the runtime, which is used to store all the static variables and the constant variables. So inside the method area, we have a runtime constant pool, which will store all your static variables as well as your constant variables also, and it is your part of your method area. So at the runtime, whatever number of static variables are, okay, static variables are there, different constants variables are there. Okay, all these things will be defined over here, and it will be part of your method area. And again, it is part of your method generation, not part of your heap memory. Okay, so if you talk about Java heap memory, in Java heap memory, always guys, it stores objects. Whatever the number of objects inside the Java heap memory, let's write some okay good notes about Java heap memory. Okay, so in Java heap memory, it stores class objects. Okay, it stores all the JRE classes, whatever the different by default JRE classes are available. Okay, all these JRE classes will be stored inside the heap memory. And always remember, guys, garbage collector GC, it runs on heap memory only. Okay, garbage collector runs on heap memory, okay, to free some memory used by the objects which does not have any references. So garbage collector runs on heap memory only to, okay, to free some memory by destroying some objects. I would say like this, by destroying some objects which don't have any references. Okay, so this is about heap memory. Okay, this is about heap memory. So in heap memory, always, okay, is stores, so not shoes, is stores. Okay, it stores objects. Okay, now let's talk about stack memory. So there are two types of memory. Heap memory, as I told you, heap memory is divided into again young generation and old generation, and memory pool is also there, which is used to store all the string classes and string pools. Okay, all the different objects will be young generation will shift number of objects from, okay, from hidden memory to survivor memory with the help of minor garbage collection. And in old generation, we will store number of objects. Old generation will take time in terms of major garbage collector. Why? Because there are so many objects are there, so it may cause some timeout issues also. So as a developer, you have to decide, okay, when exactly you have to create the garbage collector for major GC point of view. Okay, And what is memory pool? Memory pool is used to store all your string classes object, all your immutable object. A string pool also we can create inside the, okay, heap memory. Now let's talk about Java stack memory. So as I told you, this is a Java stack memory. Java stack memory, what exactly it will do? Java stack memory, it will create a couple of things over here. So let's talk about, this is heap memory and this is Java stack memory. In Java stack, sorry guys, Java stack memory, what exactly it will do? It is used for execution of a thread. So whenever the threads are running, okay, it is used to execution, okay, execute, used to execute threads. Another thing is that it contains method specific values, guys. Whenever you are whenever you are creating a method, okay, so all the methods, okay, method specific values will be stored, like all the local variables and everything will be stored inside the all the local variables. Like int I have one method, okay, let's see, public void test method. Inside the test method I have int I equal to 0. So that particular local variable, that int I is equal to 0, will be stored inside your stack memory, okay. And references of the object, sometime what happens, let's see, I have one method. Inside that particular method I have some references, okay. So all the object references also, object references, where exactly you are going to store the object references? Object references which are referring some objects in heap memory, okay, some objects in heap memory. So those object references will be stored where exactly? Inside the stack memory. So references of the other objects which are present inside the heap memory, that are getting referred from that particular method, from that particular reference. So all these object references which are available, let's say I create one method, m1 method. Inside that m1 method, okay, I create test t1 is equal to new test t, like this. So this new test t object will be stored over here, and this t1 will be stored over here, okay. So t1, this is a reference variable, will be stored, okay, over here, but this new test object will be created over here. So let's see, if I write like this, uh, let's test t1, okay, is equal to new test, okay. So this t1 is a reference variable, guys. T1 is the reference variable. So this t1, what exactly it will refer, this particular t1 will be referred to this guy, okay, to this guy, like this, okay. So reference variable will be stored somewhere, okay, inside the stack memory, that it is pointing to an object which is available inside the heap memory. So always remember, that's an interview question. Object will be stored inside the heap memory, but the reference will be stored inside the stack memory, okay, and it will refer from stack memory to heap memory, like this, okay. And it stores the value on the basis of LIFO. In stack memory, the concept is, the moment we store any value, it stores the value on the basis of LIFO. LIFO means last in first out, okay. Stores the memory will be filled on the basis of LIFO concept, last in first out. It will store all the local variables and the references of the object inside the method. So I told you that all the local variables will be stored somewhere over here, okay. Now what happens whenever, let's see, I have a method, I'll create a method for you guys. Let's see, public void m1 method is there, okay. This is the starting body, ending body. Inside the m1 method, I have written this int I is equal to 0 or maybe 10, okay, whatever, int I equal to 10 or some object I'm creating, like that. So whenever, what is happening over here, this particular method, this m1 will be stored somewhere here, okay. So whenever this particular method will be called, this m1 method will be called, what will happen inside the stack memory Java runtime environment, what exactly it will do, it will create a block, okay. It will create a simple block like this to store this particular m1 object, okay. and this particular M1 object will be stored over here. Okay, over here. M1 will be stored over here inside the stack memory. So this particular block is part of your stack memory only, but this is called method block. This is called method block. So this method block will be given to this guy M1. And once this particular M1 is done, it's completely executed successfully. Okay. Okay, this space will be unused and this space will be given to another method. Let's see, we have another method that is called public M2 method is there. Okay. Public void M2 method is there. So this particular method is done, M1 method is done, execution is done. So while we start invoking this particular M1 method, immediately space will be given to M1 method inside this particular method block. So M1 method will be stored inside the method block. Once this M1 is done, okay, this M1 is done, then the space will be given for M2. M2 will be stored over here after that once the M1 is done. So at a time, so because all the objects, all the methods are getting executed one by one, it's not like okay, parallel blocks we are creating. It's not like that. So we have method block, one by one, class methods will be executed. Once that particular method is getting executed, one method block memory, okay, will be given to that particular method. And once that method is done, then the next method will be given to method block. Okay, so when method ends, the block memory unused and become available for the next method. Always remember, if you have 100 methods, then one by one, on the basis of their execution order, on the basis of that, it will be given to the specific. So if you talk about in terms of size, so heap memory stores memory pool. Heap memory store all the immutable objects. Heap memory stores the complete young generation, old generation, survivor memory they have. Okay, so they store complete, okay, object collection. Okay, so all the objects will be stored inside the heap memory, and all the other things like we have static variables, we have methods, we have constant variables, we have method blocks are available, we have references are available, will be stored inside the stack memory. So this permanent generation is also part of your stack memory. So as compared to size, okay, as compared to size, the stack memory size is very less compared to heap memory. Okay, so always remember that stack memory size very less as compared to heap memory. Okay, this is the concept, guys. You have to remember. Stack memory size is okay is very less as compared to heap memory. This is the important concept. Okay, so this is overall JRE, the complete Java runtime environment. It works internally like this. This is complete JRE. Okay, Java runtime environment. So whenever at a time of interview they are asking about okay, what are different heap memory and stack memory, or what is permanent generation and what is method area, okay, method block, what is runtime constant pool, what is memory pool, what is heap memory, what is hidden memory, what is survivor memory, what is old generation memory, what is minor GC, what is major GC. Okay, so major GC is always performed on old generation memory. Minor GC is always performed on young generation. So in young generation, we have less amount of objects. So obviously, it will take lesser time as compared to old generation and major GC. Major GC will take some times. Why? Because old generation is having so many objects. So it will take some time to iterate all the objects, and it will take some time to destroy it. So that's why we have to plan accordingly. That okay, first of all, we have to give enough memory to old generation, and we should we should not call major GC so frequently. Otherwise, it will impact your performance of the application. The performance of the application will be degraded in that case. Okay, so that's all about Java memory management. This is very very important, guys. Like to understand how exactly Java internally, the JVM, Java virtual machine, and Java runtime environment internally works. This is called Java memory management. Okay. Java memory management. Okay, so let me know if you have any issues, if you have any questions, and if you really like this video, please share with others, and please prepare this particular concept for interview point of view. If you are going for Java development interview, if you are going for automation QA engineers, either you are a fresher or a expertise, a level experience you have, then definitely you might expect such kind of questions. If you're going for some any startup or any good product companies, 100% chances are there they will ask you, give me, do you have any idea about Java memory management? So you can draw this particular diagram, and you must know about all these terminologies, that what is heap memory, what is a stack memory. At least you should know what is the difference between heap memory and the stack memory. Stack memory is always used for method specific values, or local variables, or your static variables, or your constant variables. The complete class structure, okay, will be stored inside the stack memory. Heap memory is only and only for objects, or immutable objects, or class objects. Okay, so that's all for this particular session, guys. Let me know if you have an issue, and if you really like this video. So this is my channel name, guys. You can subscribe to the channel, Naveen Automation Labs, and there are a number of videos are coming in future with respect to these tools and technologies. And in the next session, I might cover that how exactly Java collection, I mean, sorry, garbage collection works internally. Okay, so what is the mechanism of garbage collection, what types of different garbage collections are available, uh, how to create the memory space, and how to define the memory spaces, okay, with the help of memory helpers and all. Okay, I can cover those things. Those are very advanced things, but at least you must know about all these things. So please subscribe to the channel, and let me know if you have any issues. And if you really like this video, please share with others, like the video. Sorry, guys. Like the video, and share with others, and put your comments if you have any queries. Okay, thank you so much. Thanks for watching this.